Hello, calculus students. Today we're going to be looking at something called L'Hopital's rule. This is a rule that is used for evaluating limits. We talked about limits at actually the beginning of first trimester of the school year. This is just another method that we didn't get to. But really quick, I just want to talk about what it is and how we use it. So L'Hopital's rule is used whenever you have an indeterminate form that is present after you do direct substitution. So an indeterminate form is something like 0 divided by 0 or infinity divided by infinity. And that could be a positive, minus. It really, sign doesn't matter. Those are the two indeterminate forms that we're going to be looking at. There are others, but we're going to just go with that to start. This rule is very simple to use, but you must practice proper notation and repeat the steps exactly as is demonstrated in the video. No shortcuts. Okay? If you do shortcuts or you skip steps, you will not earn full points on the AP test, so just make sure you are not trying to skip steps and save work. Yes, I'll understand you can do some of this in your head, but that's not the key. We want you to justify and show why you have to apply L'Hopital's rule. So, what is L'Hopital's rule? In general, L'Hopital's rule says if you have a function divided by another function, so if you have a fraction, and you're taking the limit as x goes to a, if you do substitution and both f of a and f of g go to 0 or infinity when x goes to a, then you end up with that indeterminate form, 0 over 0 or infinity over infinity. Well, what happens then is, to apply L'Hopital's rule, you need to see the form of the indeterminate. Once you see that form, then L'Hopital's rule is actually stating that you can take the derivative of the top function and the derivative of the bottom function and then evaluate it at a. And that will also give you the limit, assuming that the limit exists and it is not another indeterminate form. If it is an indeterminate form, then you could apply L'Hopital's rule again, and officially you can keep going if you keep getting indeterminate forms to try to evaluate the limit. So we're going to look at a couple examples here. I have them pre-worked out to hopefully go through this faster. So what do we have? We've got the limit as x goes to -3 of the function 2 tangent x plus 3 divided by the natural log of -2 minus x. Write your answer in simplest form. Well, what we're going to do is we're going to evaluate, and this is the proper notation. So watch what I'm doing. You have to take the top limit, the limit of the numerator, and you have to write that out. So the limit as x goes to -3 of the entire top part. Then we're going to do substitution. I'm just going to plug -3 in for x. We get tangent of 0. We know that tangent of 0 is 0, so the top goes to 0. The bottom, the denominator, we're going to take the limit of the denominator going to the exact same value, -3. So if I plug -3 in, when I simplify, we get natural log of 1, and we know the natural log of 1 is 0. When I compare the top limit to the bottom limit, I get the indeterminate form of 0 over 0. Now, that is not an answer that we can be happy with. However, that gives us an indication when you have the indeterminate form. Now we're going to apply L'Hopital's rule. And L'Hopital's rule states, take the derivative of the top. So let's take a look at this. The derivative of 2 tangent x plus 3, well, the derivative of tangent is secant squared. The 2 is just a constant multiplier. Keep the inside, and then I'm going to put a 1 here just to remind us that there is a chain rule. The derivative of the inside, derivative of x plus 3, is 1. Then we're going to take the derivative of the bottom. Notice there's a chain rule as well. The derivative of ln is 1 over x, but in this case the x is whatever was on the inside, -2 minus x. And then I'm going to multiply by the derivative of the inside. The derivative of the inside is -1. That's the chain rule piece. And then I'm going to evaluate the limit when x is -3. So I actually think I simplified in the next step just to kind of clear this up. I did 1 times 2 to get 2, -1 times -1 up top. Just kind of simplified this fraction. Now, all it is direct substitution. Plug in -3 in each spot where you see an x. And you can see I kind of simplified here. Negative 3 plus 3 is 0. Secant squared. Well, remember, secant is the same as 1 over cosine. Cosine of 0 is 1, so secant of 0 is 1. And then 1 squared times 2 gives me the numerator is 2. On the bottom, if we plug in negative 3 in for x, we get negative 1 over 1, which is negative 1. And then 2 divided by negative 1 is negative 2. So notice, by using L'Hopital's rule, taking the derivative of the top and the derivative of the bottom, evaluating at negative 3, we were able to figure out what that limit was when originally direct substitution resulted in indeterminate form. So we're going to do a couple more examples here that walk through this, and a few of them are just more of how is the problem presented, and then how do we do L'Hopital's rule. So if you look at this first example, given a select value of the function f and its derivative in the table below, determine the value of the limit as x goes to 1 of x squared minus 1 over f of 3x plus 3x squared. First thing I'm going to do is try direct substitution. I'm going to plug 1 into the numerator. So taking the top part, plug in 1, we get 1 minus 1 is 0. I'm going to plug 1 into the bottom, notice function notation. If I plug 1 in here for x, I get 3 times 1, which is 3. So f of 3 plus 3 times 1 squared is 3. Now comes the use of the table. F of 3 is equal to negative 3. You can see that in the table. And then negative 3 plus 3 is 0. When I compare the top and the bottom, I get the indeterminate form. So that's not an answer, but it is our sign to take and use L'Hopital's rule. So reiterate, you have to show the limit of the top going to 0 and the limit of the bottom going to 0. You can't do them together as a fraction. You have to do them individually and then show that when you compare them, you get indeterminate form. Now, we're going to take the derivative of the top and the bottom. We're going to apply L'Hopital's rule. So, take the derivative of the top, we get 2x. The derivative of the bottom is function notation. F of 3x, the derivative of f is f prime, keep the inside, and then we multiply by 3. There's my chain rule again. And then plus 6x, because the derivative of 3x squared is 6x. Now, I don't really need to simplify anything. I'm just going to do direct substitution. I'm going to plug 1 in everywhere I see an x. And this 3 is just the chain rule 3 written on the outside. I prefer the 3 on the outside. So now, we'll simplify. We get 2 up top. We get f prime of 3 plus 6. Well, f prime of 3, we can find that in our table. Look at f prime of 3 is positive 3. That's the slope at 3 of the tangent line. 3 times 3 is 9. 9 plus 6 gives me 2 over 15. And that is a solution that we are happy with. Okay, we got 2 more problems. And what I would recommend doing on this is try it on your own. Hit pause, try this problem, and then take a look back at it. Actually, before you hit pause, you need to know some information, and I'm revealing part of the answer by doing that. This one has a graph now, so we have to be very careful with how we think about this problem. So if you'd like to try this on your own, hit pause. If not, I'll go through the answer. So we're going to take the limit as x goes to 2 of this function. Notice there's an f in there, so we're dealing with function notation. Top limit, we're going to plug in 2, and we get 0. Bottom limit, if I plug in 2, notice right in the bottom here, we get 2 times 2 is 4, and they're asking me for f of 4. Well, what does that mean? F of 4 is what is the output when x is equal to 4. So there's where my graph comes in. I'm going to go over 4, down 4, and you can see that the output when x is 4 is negative 4, and there is your output. So I get negative 12, everything else simplifies to 12 on this side, so we get negative 12 plus 12 is 0. When I compare the top over the bottom, there is the indeterminate form of 0 over 0, which means that's our sign that we can apply L'Hopital's rule. So now we're going to take the top derivative, which is just 3, over the derivative of the bottom. Now again, chain rule, 3 is a multiplier here. The derivative of f is f prime. Keep the inside, and the derivative of the inside is 2. And then the derivative of 3x squared is 6x. Now we can do substitution again. I just simplified this. This 2 and the multiplier 3 would combine together to give me a 6 out front. So now we can do direct substitution. I'm going to plug in 2 into each spot wherever there's an x. And then we're going to simplify, and notice now they're saying what is the derivative at 4? What is f prime of 4? Well, they don't directly tell us that, but we know that derivative is the same as the slope. So what is the slope? When x is equal to 4, I'm going to find this is a nice, friendly, linear equation. I can check the rise over the run, and I get a slope of -2. So f prime of 4 is -2. I'll plug that right in here. And then when I simplify, I get -12 plus 12 on the bottom and 3 on top. Well, this is not an indeterminate form. This is an undefined solution because you cannot divide by 0. And since the numerator goes to 3, we know what that is, but we don't know really what the bottom is. So my overall answer is does not exist. All right, final example. This is one that I think you guys could completely do on your own, so I highly recommend just hitting pause, trying this example. Notice there's no function notation, and then just see what you get. Okay, I'm going to show you the whole thing and go through this really quick. Top limit, plug in -3, it goes to 0. Bottom limit, plug in -3, you get the natural log of 1 at some point, which is 0. That goes to 0, so my indeterminate form is 0 over 0. That tells us to use L'Hopital's rule. So I'm going to indicate to the person reading this that I'm taking the derivative, by L'Hopital's rule, of the top. We're going to take the derivative of the bottom. This is the natural log of -2 minus x, which is 1 over -2 minus x. And then don't forget this -1 came from the chain rule. I simplified things, -1 times 4, and then I put it in the numerator right here for the bottom fraction. Now I'm going to plug in -3, simplify, and I get 3/2. There it is. That's L'Hopital's rule. Please remember, do not skip steps. You have to show the top limit going to 0 or infinity, the bottom limit going to 0 or infinity, and that's our sign that it's an indeterminate form. So you have to show this work and then indicate that you're using L'Hopital's rule. And there you go. All right, homework tonight is on Delta Math, so good luck to you. Reach out to me if you have any questions.